y'all. It's that time again. It's Math with Mrs. Peters, the crazy cat lady of Hiram High School. And today, now, we graph. We're going to take all that stuff, all that information that we had on all the pieces for rational functions that we've been doing, those 6 things, and now we're going to put them together and draw a picture. So, here I have a function. And I've done all 6 of those lovely things. And so, I have my factored form, I have my no holes. Yay, no holes. I have a vertical asymptote at -3. And look, I drew it in with a dashed line. Drew it in with a dashed line for a reason, because we're not going to cross it. And if you draw it in with a solid line, I'm going to mark you wrong. Okay, I have a x-intercept at -4, so I'm going to grab one of these guys and put it right there. I have a y-intercept at 0 and 5/8, which I've converted to a decimal, which is 2.66, so that's just about right there. Okay, I have a horizontal asymptote at 2, right there, again, drawn in with a dashed line, because I'm not going to cross it. And now I'm going to get out my handy dandy ever popular calculator, and I am going to type the value in my table in, and I am going to let you see the ordered pairs I come up with. So here's my lovely calculator. Slide it over here so we can see our graph at the same time. Now, what a lot of y'all probably don't realize is even though my y values here are in fraction form, I can make my calculator turn them into decimals for easy graphing. So 8/5, okay, if I toggle over to here, and then down here, see this little back and forth arrow? If I hit it, it'll change my y value into a decimal. So that's 1.6. I'm going to come up here and I'm going to go, okay, so at -8, I'm at 1.6, which is right here. Okay, we'll toggle down. I'm going to put a couple more points in. Let's say at 6, I'm at 1.33333333. So that is just a little bit higher than 1. Okay, and let's look at what happens at 5. At 5, I'm actually at 1. That's great. Right now, I'm going to scroll down. At 4, I'm at 0. I'm already there. At -3, I'm error. That error is represented by this dashed line called a vertical asymptote. Okay, at -2, I'm at 4. At 3, I'm at -1. Excuse me, -1, I'm at 3. So we have a sort of a general idea of what's going on with my graph. So now I can get out my handy-duty, ever-popular pen, and I can draw my graph. Now, I want you to notice, we've got a curve going on. This is not stopping at -8. It actually goes out from -8, crosses through these points, and keeps going. And if you notice, I'm not actually drawing on top of my dashed line. And I'm putting arrows on because this continues forever and ever and ever. And if you typed it in Desmos, you would see that it keeps getting closer and closer and closer. Okay, and I have the same situation going on here. I got to make sure I go through those dots. Oops, that wasn't very good, was it? Let's try that one again. Oh, that was bad too. And keeps getting close. Put my arrows on. And I've graphed. So, let's look at another one. Okay, here again, I've done those 6 things that I asked of y'all. Okay, I have a vertical asymptote at 3. Where is my line? Oh, I'm just going to have to go draw my line myself. Okay, purple line. We're going to make a dash. Arrows on either end. So here's my purple line. Move it over just a smidge so it sits right there. I have a horizontal asymptote at y = 0. Y'all, y = 0 happens to be the x-axis, so it's right there. Again, we got dashed lines. I have a no x-intercept. I do have a y-intercept at 0 and just over at 0.67, and I have a hole. Okay, now a hole has to be represented by actually having, let's see, well, there we go. I have line color and my fill. Oh, look, it's a hole. It has nothing on the inside. In fact, you know what I'm going to do? I'm going to help you out even further. I'm going to make my line not quite so big so that we can see that it's actually a hole. And my hole is at 2, 2, which is right here. Now, I'm going to get out my handy-dandy Everpopio calculator again. I'm going to type in the lovely information, and I'm going to pull up my calculator, as you can see right there. All right, I'm going to enter. I'm going to start at maybe -4. All right, so at -4, I'm at, about a quarter. I'm sitting at -4. I'm sitting almost on my dashed line. Okay, scroll down. Let's see if I have any nice points. At -1, I'm at 1/2. So at -1, I'm exactly at 1/2. Okay, what happens at 1? At 1, I'm at 1. I like that. So now I have a good idea what's going on this side, on the left side of my vertical asymptote. Okay, there's my vertical asymptote showing up. Ooh, it looks like, oh, that first one there, that's my hole. My second one's my vertical asymptote. At 4, I'm at -2. So all of a sudden I jump down. Okay. At 5, I'm at -1. Alright. At 6, I'm at -2/3, which handy for me is really 0.666666. So I'm getting close to that line here. Right now, I'm going to draw. Get out my pink pen. And I'm going to draw, making sure that I do not cross the dashed lines. Come up to my hole, keep going, keep going, keep going, keep going. Draw my arrows. All right, again, over here. Draw my arrows. And we're graphed. So, that's all you have to do. Make sure you use your calculator for your table of values. It makes it a whole lot easier than having to type each little thing in and get it. And some of our problems may have 2 vertical asymptotes. So we'd have 2 vertical lines. Anyhow, if you have any questions, write them down, bring them to class or tutoring, and I'll be happy to answer them. I know y'all can do this. You guys rock. See y'all later. Bye.